Hello and welcome back to Dr. Logic awkwardly does logic in her bedroom. This is going to be the first video in a series of videos where we look at the soundness of the proof system that we've developed for the syllogistic. So what we mean by that is we are going to show that the axioms we've chosen and the rules that we've defined correspond to the generation of valid syllogisms according to our semantics. So proofs talk about propositions at the level of structure and form and give us rules for how to change these structures and forms, or how, given the presence of propositions of a particular type, we can write down propositions of another type. But we want to connect this back to the definition of good syllogism that we had a couple videos ago in terms of necessary truth preservation. So the idea that any interpretation that makes the premises true will also make the conclusion true. So we want to show that any syllogism that we can derive using our proof theory will be valid according to this definition of validity. That is what we mean by the soundness. So we will need to show that each of our axioms is itself a valid argument, and then we will have to show that each of the types of rules we've defined are truth preserving. If we start off with true propositions, we will never derive false propositions from them. So in this video, I want to look at the validity of our basic axioms. So we had 4 of them: Barbara, Celerant, Dari, and Ferio. Now, I'm only going to prove you the soundness of 2 of them, Barbara and Ferio, but the method that I use can be generalized, and you can give it a go and try to prove Celerant and Dari yourself. It's a good exercise to make sure you really understand how these interpretations work. But let's bring up the whiteboard so that we can start jotting things down. So the first thing that we should do is just remind ourselves what the syllogisms Barbara and Ferio are. So they are both first figure syllogisms. That means that they have this structure. So predicate, copula, middle term for the major premise, middle term, copula, subject term for the minor premise, and then predicate, copula, subject for the conclusion. And then, if you remember from the mnemonics video, the vowels in the names tell us what the copulae of the propositions are. So Barbara is P-A-M, M-A-S, therefore P-A-S. And then we have exactly the same structure for Ferio, but take a look at the vowels. We have P-E-M, M-I-S, P-O-S. So there are the 2 basic axioms that I'm going to prove are valid. What we need to show is that every interpretation that makes the premises true also makes the conclusion true. The way that we are going to do this is not by surveying every possible interpretation. There are infinitely many of them. We don't have that kind of time. What we will do instead is say, well, suppose that we have an interpretation that makes both of the premises true. Is it possible that it also makes the conclusion false? So we will try to assume the opposite of what it is we are trying to prove. We want to show that suppose there is an interpretation that makes the syllogism invalid. And then what we will show is that this will lead us to a contradiction. It will put us into a situation that cannot be maintained. There can't be any interpretation of that type. So you might remember when I was introducing the reductio ad absurdum method within the proof syllogism, we had this same sort of technique. Assume the opposite of what you want to show is true, and then derive a contradiction from that, and then conclude, okay, my original assumption was off base. It has to be that it's contradictory is what is true. So it's the same technique that we're using here, but rather than doing it within the proof system, we are saying something about the proof system. So we are doing these proofs at the meta level, though the techniques that we use in doing meta level proofs are often very similar to ones that we use doing object language proofs. So what we want to show, we'll start off with the soundness of Barbara. And we will ask, is there an interpretation I that makes PAM true, MAS true, and PAS false. So another way that we can write this is there one that makes I double turnstile PAM, I double turnstile MAS, and same interpretation I double turnstile with a slash through it, PAS. The first thing to remember is that if a universal affirmative claim is false, its contradictory has to be true. Its contradictory is a partial negative. So we can rewrite this is there an interpretation where PAM is true on the interpretation, MAS is true on the interpretation, and so is POS. Now, in order to answer the question, is there interpretation that does these three things? In fact, I'm going to go and I'm going to label them 1, 2, and 3 so that we can come back to refer to them. Well, let's try to construct one. Let's take a look at the third thing first. So since, hypothetically, on this interpretation that we are trying to construct, POS is true, it follows from the definition of truth that the interpretation of S is not a subset of the interpretation of P. So let's start just kind of keeping track of what these interpretations might look like. We have the interpretation of S, the interpretation of M, and the interpretation of P. These are each going to be sets that we define. Now, this first condition, so this is following from clause number 3, we know that there is some objects, let's call it B, that is in the interpretation of S and is not in the interpretation of P. So I won't put anything in there right now. Now, by our second clause, we know that the interpretation of S is a subset of the interpretation of M. So everything that is in S, so right now we've got B in here, is also going to be in the interpretation of M. So let's move and put our B into the interpretation of M. This is forced by assuming that the minor premise is true. Now, if we look at our major premise, we also know that the interpretation of M is a subset of the interpretation of P. So that means everything that is in our interpretation of M, which includes object B, also has to be in the interpretation of P. But let's get a different color. Problem, because as soon as we put B into the interpretation of P, then this is no longer true. Then the interpretation of S does become a subset of the interpretation of P. And so you might ask yourself, okay, well, then maybe this is just something that happened with B. Let's go back and actually put another object into the interpretation of S. Let's call it C. Now, here's something. We've got something that's in C, in the interpretation of S, that's not in the interpretation of P, object C. Okay, our conclusion is now false again, or clause number 3 is true. But you can see that exactly the same thing would go. We would then be like, oh, but since S is a subset of M, I need to put it in here. But since M is a subset of P, I need to put it in here. Problem! So this will happen whatever the interpretation is. By this, so the fact that we have, we know that B has to both be in the interpretation of P and that B is not in the interpretation of P is a contradiction. So that means that there is, in fact, no way that we could make all of the premises of Barbara true under the conclusion false. Anytime that we tried to do it, we would run into exactly this contradiction. So that's that. Let's see, I'm going to go ahead and clear all drawings, and don't worry, I'll write Ferio again up here so that we can prove its soundness. So this is PEM major premise, MIS minor premise, POS conclusion. So again, to prove the soundness of this of this syllogism, we need to ask, is there an interpretation I such that, and who? I don't think I've introduced this abbreviation before. S dot T dot. This is the logician's favorite abbreviation for such that. We say it a lot, and this is much shorter to write. So is there an interpretation I such that these three things are the case? I makes PEM true. I makes MIS true. And I doesn't make POS true, which, by the same sort of reasoning that we had in the other case, if POS is not true, it has to be false. If it is false, then its contradictory is true. Its contradictory is the universal affirmative. So this is just the same as saying I makes PAS true. Is there such an interpretation? Let's try to construct one. I'm going to start by looking at clause 2, which says that MIS is true. So what we know is that if you take the interpretation of M and the interpretation of S, and you look at what is in both of them, you have at least one object. You don't have the empty set. So let's suppose that the object that is in both the interpretation of M and the interpretation S, let's call it B again. It's a handy letter at the beginning of the alphabet. So in trying to construct such an interpretation, we'll put B in both the interpretation of M and the interpretation of S. And then at some point, we'll have to say what goes into P. So by 3, we know that everything that's in the interpretation of S is also in the interpretation of P. So that is just the truth condition for the universal affirmative. So that means we have B here in this set. We also need to put it here in this set. Now, let's look at our major premise. This one says that if you look at the set of things that is both, sorry, this needs to be P, that is both in P and in M, you should get the empty set. So there should be nothing that is in both of them. However, look at this problem. You've got B occurring both in the interpretation of M and the interpretation of P. So we would have to scribble it out from one of these. Now, if we scribbled it out from M, then we would then it's no longer the case that there's something both in M and S. So we would have to add something. Maybe we can add C there instead. But then it also needs to go into S. So let's put it down there. But look, by the third clause, we know that anything that we put into S, we would have to put in C. Oh, look, we are back in problem land again. So just as with Barbara, we can see that any time that we try to kind of rehabilitate this interpretation to make it into one that can make the premises true and the conclusion false, we will always run into this issue that we need to have something that is both in M and S, is not allowed to be in both M and P, but has to be, if it's in S, it has to be in P. This is inconsistent. We can't do it. So again, we know that having the intersection of M and P equaling the empty set and the intersection of M and P not equaling the empty set is a contradiction. So our attempt to come up with such an interpretation failed, and if we turn this into a question, then the answer is a great big no. There's the soundness of Ferio. I won't do Taylor and Tandari. I will leave that for an exercise for the reader, something else logicians love. But it's going to be exactly the same sort of thing. Try to come up with an interpretation that makes the premises true and doesn't make the conclusion true, i.e. makes the conclusion false, i.e. makes its contradictory true. Write down what this means in terms of interpretations and the definitions of truth. Try to construct an interpretation that meets all of these conditions, and you'll end up in trouble. So give it a go. If you fancy putting your answer in the comments, I'll take a look and let you know how you're going. And join me next time where we will look at the soundness of the transformation rules, showing that if we start off with a true proposition, applying one of the transformation rules will result in a true proposition. See you then. Cheers.